Okay, good morning, everyone, and thank you for joining our Database Cloud Services Office Hours. Today, I'm really excited to have Sriram Virunda join us. Hi, Sriram, how are you?
Good, thanks, Tammy. How are you?
I'm good, thank you so much. And today we're going to talk about managing autonomous databases with Enterprise Manager. You know, Enterprise Manager has been around for as long as I can remember. It feels like I've been with Oracle for several years. Hi, my name is Tammy Bednar, by the way. I'm a Senior Director of Product Management for the Database Cloud Services. And I want to thank everybody for joining us. If you could stay on mute during the presentation, that'd be great. Please feel free in the chat box to ask any questions during the presentation. If there's some really good questions, I'll interrupt Sriram during his presentation to ask him, or hopefully we'll have some time at the end and we can answer them that way, or if you'd like to ask them live, more than happy to unmute you to have you ask them live as well. So I won't delay any further. Sriram, thank you so much, and why don't you take it away?
All right, thanks, Tammy. Thanks, everyone, for joining the session. We'll get started without further delay. So here is the agenda that we have for today. We'll get started with an overview about autonomous database. I won't spend much time. So here the idea is to understand what manageability solutions do we have for autonomous database. We'll look at the DBA responsibility shift in the autonomous world, and we'll make it interesting with a couple of cool live demos in terms of how do we manage autonomous database with Enterprise Manager, and we'll take up questions at the end, or in case if you have any pressing questions, as Tammy suggested, feel free to interject and then we can take it up at that point in time. So this is the safe harbor statement. I will let go a minute or a moment so that you can go through this. And this is to make sure that these are future product directions that we might discuss, and just to have it on the safer side. So that's the safe harbor statement. So now let's get started with autonomous database. So Oracle Autonomous Database is the world's first autonomous data management solution in the cloud to deliver automated patching, upgrades, and tuning, which also includes all routine database maintenance tasks while the system is running. So this new autonomous database cloud is self-driving, self-repairing, and self-securing, which helps to eliminate the manual database management and human errors. Autonomous database is fully elastic in the sense that you simply specify the number of OCPUs and the storage capacity in terabytes for the database. And at any time, you may scale, that is, increase or decrease either the OCPUs or the storage capacity. Oracle Autonomous Database is actually a family of products with each member of the family optimized by workload. The first member of the family to become available was the Autonomous Data Warehouse, which has been optimized for analytic workloads, such as data warehouse, data marks, or maybe part of a data lake. The second member of the family is Autonomous Transaction Processing, or ATP, which is optimized for transaction processing or mixed workload environments. And that makes an excellent platform for new application development. Now, having said that, the Autonomous Transaction Processing Cloud now offers two deployment choices, the serverless and the dedicated, that is ATP-S and ATP-D. With serverless deployment, the simplest configuration that you have, multiple customers share the resources of an Exadata cloud infrastructure, and these customers can quickly get started with no minimum commitment, enjoying the quick database provisioning and independently scale their compute and storage. Autonomous Transaction Processing Dedicator, or ATP-D, is a deployment choice that enables customers to provision autonomous databases into their own dedicated Exadata cloud infrastructure, instead of they sharing the shared infrastructure with other tenants. The dedicated deployment provides the customer the customization over operational policies, including software and hardware isolation at the highest level of performance and security governance. Hence, it is well suited for customers wanting to deploy Oracle database in the cloud with common enterprise lifecycle controls, and especially ideal for customers who want a private self-service capability within their own private database cloud within a public cloud. Now, currently, both deployment options, that is serverless and dedicated, are available with autonomous transaction processing. As we speak today, Autonomous Data Warehouse only supports serverless deployment. Today's discussion, we are going to talk about how do we manage autonomous dedicated using Enterprise Manager. So before we get there, what options do we have for manageability from an autonomous database perspective? We said that autonomous database is self-managing, self-repairing, and self-driving. So what do we need to know from a manageability perspective about autonomous databases? Let me take a step back and introduce you to the world of traditional DB admin responsibility, and then understand how this is going to shift in the autonomous world. From a traditional DBA responsibility, if you look at that, we categorize them as two specific buckets. One includes the maintenance tasks, and the other one is into the bucket of business innovation. What specific tasks that you perform to be more aligned with business and to be more aligned with the business innovation. The maintenance tasks include configuration tuning of systems, network, storage. You would also do provisioning, patching, database backups, HA, disaster recovery, maintaining indexes, maintaining baselines, etc. But on the other hand, when you look at the business innovation and the business value add that you would do application related tuning. You would also be responsible for cross-tier application diagnostics. How do I stitch in the end-to-end story? If there is an application performance problem, how do I correlate that to the database from the application? And data movement is something that is very much keen to you in terms of test dev systems, maybe upgrading systems and get to a newer version of the software to understand that the business is aligned with the new technology uptake. And also that relates to the data lifecycle management, where you would closely align yourself with the new test dev strategy, wherein the test team and the functional testing teams can quickly test any kind of deployments that they might want to test. Now, in the autonomous world, all these maintenance tasks that we talk about is taken care by the autonomous database. Now, when you talk about the high-value business and innovation, that's where Enterprise Manager comes into picture, wherein you can do all sorts of application-related tuning, cross-tier application diagnostics. It also helps you to do data movement and also sets you up with the data lifecycle management. And in addition, you'll also be interested in doing manageability tasks related to application, related to security. And that's where Enterprise Manager comes handy, and that's the solution or the tool that you would use to be aligned with business and be more innovative. That leads us to the discussion around the DBA responsibility shift. So these are the high value operations that you would do in alignment with the autonomous DBA tasks, wherein you would perform data movement and cloning. And once you have done that, when you have moved your databases from on-premises to the cloud to the autonomous DB, you need to do monitoring and alerting so that your applications are continuously up and running, and any kind of application related tuning that you need to do have to be in line with the support for monitoring and alerting. And once you understand there are some key issues that needs to be unearthed from an application perspective, you might want to do deep performance diagnostics and troubleshooting so that your application SLAs are really met. And then you might also want to do capacity and performance insights based on historical data. That's where you kind of end up with diagnose and analyze. So based on this, we have these themes wherein you would do monitoring, you would do data movement, you would do management from an application perspective, and also do diagnostics and analysis from a performance and capacity insights based on historical data. So today's session, we will cover this as this theme, wherein we'll get started with managing autonomous databases with Enterprise Manager. And one section that I have clearly pointed out is the Discover and Monitor. Discovery is something that you might be familiar with EM if you've been using EM for managing other databases, including on-premises or the OCI user-managed DB systems. In order to get to manage a database, you need to first make sure that EM understands that database, and that's where discovery comes into picture. Now, before we get into the discussions around EM and its capabilities, we would also like to take a pause here and try to understand what are the different types of service interfaces that you would deal with when you talk about autonomous databases. Autonomous database actions are exposed through the OCI console and REST APIs. This is the place that you would start creating your databases. You would start defining your backup policies. You might want to actually do a start, stop, or maybe restore operations. So this is the lifecycle management console that you would deal with, wherein you might want to deal with provisioning of CPUs and storage, etc. And for monitoring, you have a cloud dashboard, which also has Performance Hub. And in addition to that, if you are an enterprise customer who would have like maybe majority of the databases on premises and a couple of them getting moved to cloud, then you might want to have a single pane of glass view so that we can enable the hybrid cloud monitoring. And that is where Enterprise Manager Cloud Control comes into picture. But regardless of the tool that you use, whether it is OCI console or SQL Developer Web or EMCC, depending upon your persona, you would end up talking to the Oracle Autonomous Database and the related performance views that are core and contained within the database itself. So if you're talking about Performance Hub or SQL Developer Web, you generally talk to the database via the inbuilt PL SQL stored procedures. And that's exactly the place that we actually talk about when we deal with multiple consoles. So be it a fleet administrator, be it a departmental administrator, or maybe a developer, you might probably end up using different set of tools, but end of the day, the service interface would talk to the autonomous database and the management logic resides within the database. So you get to see the same set of data. So you have a single set of API for collecting metrics, but they are just exposed via various consoles, and you end up using them depending upon the persona that you are dealing with. So if you are a fleet administrator, maybe the best choice is Enterprise Manager Cloud Control. If you are a developer, then SQL Developer is the tool of choice. And OCI console would be used if your databases are predominantly within the cloud itself, if you don't have a majority of hybrid cloud presence. So that's how we kind of look at it. But end of the day, the management logic resides within the autonomous DB itself. So now let's get into the discussions around the management of autonomous databases with Enterprise Manager. So as I said, the theme here, we said that we will do discover and monitor, move, manage, diagnose, and analyze. Kind of introduced what these themes are in terms of the high value operations that you would perform as autonomous DBA. So the first thing that we need to do is to make sure that the Enterprise Manager console understands that we have an autonomous database to be managed. And when we talk about autonomous database, one thing to note is that autonomous database does not give you any kind of host level access. All you get to know is the application endpoint via the DB connect string, and how do I get to that database using the connect string. If you're familiar with Enterprise Manager monitors and manages databases via the concept of Enterprise Manager agent. And that agent would reside on the same host where the database resides. But in this case, we can't have access to the host. So how do we deal with this scenario? Autonomous databases are treated as non-host targets and are discovered manually using a declarative process. EM already has this framework wherein it can treat non-host targets. And we still need an EM agent that would monitor the health and performance of autonomous databases. And this agent would run on a remote host, a host other than the autonomous database host, and that host would be either on-premises or on your Oracle Cloud infrastructure. Now, post-discovery, the EM agent would start monitoring an autonomous database and display the comprehensive set of metrics, and also you could perform deep diagnostics and management the same way that you would deal with any other database. Now, to give a pictorial representation of how this thing would work out, if you look at the picture here, we have the enterprise manager on premises, and you would have a set of agent hosts, which could be any host where your enterprise manager agent would be running, which is currently monitoring any on-premises databases. We could extend this host to connect to Oracle Cloud infrastructure and make sure that they talk to ATP instances and they can discover and monitor the ATP instances running in the Oracle Cloud infrastructure. So autonomous database essentially will be monitored by an identified EM agent, which would be a regular agent running either on-premises or within the Oracle Cloud infrastructure. This agent is a regular EM agent on a host at the customer's premises, that is in your data center, or on OCI, which has equivalent access to the ATP database. Now that would allow us to discuss more about the connectivity options and what type of deployment options do you have in case if you want to manage EM within OCI or outside of OCI wherein it is deployed on premises. So we have two deployment options depending upon what you would want to use. Enterprise Manager can be deployed on Oracle Cloud Infrastructure Marketplace, which means that all your monitoring and the targets are within Oracle Cloud itself. So in this case, you would see that an EM instance running behind the firewall in availability domain 1 in the public subnet, and you talk to the Enterprise Manager over the public internet via the internet gateway, and that's it. The rest of it behind the scene would be autonomous dedicated, which are not exposed to the public internet, but EM through the inbuilt OCI firewall rules and security principles would talk to autonomous dedicated, and you could also monitor the autonomous dedicated instances along with the web server components if you want to do that. So this is one deployment option where an enterprise manager deployed on OCI Marketplace allows you to discover and monitor autonomous databases that are deployed in a private subnet. If you are an enterprise customer and you have a huge bunch of on-premises databases to be managed, and you have a huge mammoth deployment of Enterprise Manager already running on premises, and you are shifting your databases onto the cloud and shifting it to the autonomous world slowly, then you might want to reuse your existing Enterprise Manager deployment on premises. This is where we support and honor the OCI networking capabilities in terms of Fast Connect or IPsec VPN over the public internet, wherein EM can be configured as an extension to your on-premises data center and talk to OCI infrastructure, wherein you can talk to the autonomous databases using any of these methods via the dynamic routing gateway. So you don't actually traverse the public internet, but rather you have a Fast Connect or a dedicated line that allows you to extend the on-premises data center to OCI or the Oracle Cloud Infrastructure Data Center. So these are the two deployment options. So regardless of whether you're an on-premises enterprise or you are a small medium business wherein you want to deploy your entire stack within Oracle Cloud Infrastructure itself, you have the capability to do that. So that leads to the discussion around discovering an autonomous database target. How do I discover? So we now know that there are multiple ways to talk to ATP instances, either from on-premises EM or from OCI Marketplace EM. Now, let's understand how this discovery process would work. And we also need to deal with certain set of user personas when we talk about discovery. Some of these users are related to Enterprise Manager. Some of these users are related to ATP target, which is the target user or the target DB user. From an EM perspective, you would deal with the Enterprise Manager super user. which is sysman user, which has the privilege to create additional set of database administrators and grant them the privileges to manage what type of cloud targets they would manage, or maybe they get privileges assigned from the sysman user so that, okay, you go ahead and manage a couple of ATPD instances. And once that is created, the EM admin can log on to EM, and they are capable of adding or deleting autonomous DB targets and monitoring the databases of their interest. So that's the EM aspect of it. Now, in order to add and delete autonomous DB targets, the EM admin user would also need to know the target DB users. And from that perspective, we define two set of users. One is the admin user, which is the primary administrative account in the database. And EM relies on this user for real-time database management. Real-time database management like Performance Hub, Ash Analytics, or SQL monitoring. Monitoring user, which is called as ADB SNMP, which is an out-of-the-box created user when you create an autonomous database. And that user would allow you to collect PDB metrics. And this is created again as a seeded user within ATPD. All you need to do is, once the database is created, you need to go ahead and unlock this user and reset its password. So the password rotation would be done by you as the end user. So these are the set of user personas that we need to understand when we talk about discovering autonomous database targets. Now, how does this fit in from a user experience perspective? So for creating the databases, the ATP database, you need to log on to OCI console. So PDB admin would create the ATP database from the OCI console, and you need to download the credentials wallet. Once you have the credentials wallet, then you need to come to EM. If you're starting afresh, you can install EM on OCI Marketplace, or you can configure or use the existing on-premises EM to talk to OCI. Now, once that is done, you log on to EM and you are ready to perform a manual discovery either via the UI or through the EM command line interface. What you need to give as an input is to upload the credentials wallet that we already downloaded in step 1. And you also need to provide the monitoring user credentials, unlock it if required. And if you've not done that, you probably need to unlock it the first time after you created the DB. And then you might also want to key in the ATP admin credentials for active management for using Performance Hub or advanced performance diagnostics capability. And we assume that all the connections coming over from on-premises would be over VPN or Fast Connect, because ATPD is in a private subnet and you can't talk to ATPD over a public network. Now, once that is done, ATPD instances or databases are discovered and are ready to be monitored via EM. So that's the user experience, and maybe I can do a live demo rather than going through screenshots to see how this entire demo, entire discovery workflow would look like. All right, so I am logged on to EM, and I also have the OCI infrastructure. So what I would do as a PDB admin or a database administrator who manages autonomous databases, I would come to this portal and I would click on Create Autonomous Database. And in order to create autonomous database, I need to choose a compartment of my choice, and I can give it a display name and a DB name. And here you would select the workload type. In this case, I've selected transaction processing and select dedicated infrastructure because it's ATP dedicated. You specify the CPU core count storage, and you also need to specify the autonomous container database. And that is something that would be created for you by the fleet administrator. So you need to work with your fleet administrator to understand what this container database is and which container database to be used for creating your autonomous database. In this case, I'm using the workshop container, which has been provided to me by the fleet administrator. And this is the only place that you need to work with the fleet administrator to understand what is my container database. Now, once I have that, I key in my administrator credentials. You just need to key in your password, and then you are good to go. When you click on Create Autonomous Database, the database would be created in less than 5 minutes or so. So I'm not going through the entire workflow. I already have a database created, and in this case, it is EM ATP DB. So I can go to this details page and try to see if things are up and running. So in this case, I see that the database is available. The next thing that I would do is to download the credentials wallet. I click on the DB connection, and in here I can click on the download button, which would allow me to download this wallet in a zip file format. And this credentials wallet is what I would use to discover the autonomous DB through EM. So this is the OCI part of it, wherein as an autonomous DB admin, I would come and create this and download the wallet. And once I have the wallet downloaded, I go to Enterprise Manager. And within Enterprise Manager, I can go to Setup, and I go to Add Target, and I can say Add Targets manually. And as we said, autonomous databases are non-host target, which means that we don't have access to the host. And the only way that I could discover autonomous databases are using this process of adding non-host targets using a declarative process. So I click on Add Targets declaratively. And this host that you see here is the host where your agent runs. In this case, I'm going to use the same host where my OMS or the Oracle Management Server runs. So I'm not using any other agent. I'm using the same agent where the EM is running or the OMS is running. So if you want to choose a different agent, you can do that. To make it simple, I'm using the same box where my EM runs, and that I'm using this agent to talk to ATPD. I can just type in auto, and then automatically it pops up this target type, which is the autonomous transaction processing target type. I click on that and select add. And in here, I can give it a meaningful name for the target. I can give it as ATP demo. And this is where it would ask me to choose the credential wallet that we downloaded from OCI. I click on choose file. And here I have downloaded this wallet already. I upload that, and you see that all the details are automatically populated. All you need to do is to unlock the ADB SNMP user via SQLnet, and then you can key in the password, and we can do a test connection. And the test connection was successful, which means that we are good to go, and I can add the database. So this is all discovery. It's just a simple step process to do a discovery, nothing fancy about it. It's getting done, but in the meantime, I can explore the databases that I've already discovered, and we can actually go to that database and see how it works. So this is about the discovery demo. So let me come back to my presentation here and continue with the other themes. Now, once we have discovered the database, the next thing that we need to do is to do comprehensive monitoring. So what monitoring capabilities do we have for monitoring Autonomous DB? Autonomous DB can be monitored via the DB homepage, and it gets important metrics related to your performance, and also metrics related to whether the targets are up and down or not. So basically, you will get the real-time performance charts, and looking at those charts, you can drill down for any kind of active management. And these performance charts are based on metrics that are collected behind the scene using the ADB SNMP user. And that's why we key in the ADB SNMP user as the monitoring user, who would collect metrics from ADB, from the autonomous DB, and they are persistent within the EM repository, so that you can go back and do any kind of trend analysis or any kind of analysis that you want against these metrics. So the visualization to that is your ATP homepage or the DB homepage, and this is how it would look like. And you have the performance section, which talks about the average active sessions. You have a resources section and a SQL monitor section. We'll come back and revisit those pages once we conclude this section here, and once we conclude the theme around the manageability options. So this is in essence how the ATP homepage would look like. Nothing fancy here. It's the same DB homepage that you've been dealing with any other database. The next theme is around data movement, and this feature is not yet out there. So this is a coming soon feature. We will introduce the migration workbench. It's currently under preview in development. So what this means is that we allow you to plan, migrate, and analyze your migration strategy. We have a consolidation exercise that we will do wherein you have a sizing advisor, which comes up with a plan, and it comes up with a data migration strategy to migrate your databases to either autonomous database or non-autonomous databases. And finally, once you're done with the migration, you also need to understand or analyze the performance and accuracy of the database after migration. In essence, this is what it does. Planning, wherein assess the impact of consolidating multiple databases into a single target database. So you need to estimate the size of the destination database for optimal performance. If you're moving to autonomous dedicated infrastructure, you need to know the Exadata infrastructure requirements. So that's what this does for you. Migration, you can actually use any of the supported migration methods, data pump for autonomous databases, RMAN or Active Data Guard for any other user-managed databases. And finally, you might want to analyze the migration accuracy so that you can compare the performance of the database before and after migration using the well-known SQL Performance Analyzer tool. So that's about migration. It's a coming soon feature. Now, from a manageability perspective, what do I manage for an autonomous database? You need to have security features that allows you to control how a database is accessed and used. So you need to manage users. You need to do privilege analysis and do auditing of your database. That's supported through EM. Schema management, comprehensive tool that allows you to manage all aspects of database objects and things like tables, indexes, views, etc. Storage management, autonomous database dedicated allows you to have some granular control over table spaces, unlike the autonomous data warehouse. So you can have the capability to view and manage a couple of the storage structures related to autonomous databases. That's where the storage management comes into picture in case if you want to have a view of what's happening or how is it that my autonomous database is managing my storage, you have a read-only view for that. Now, from a performance diagnostics perspective, you have Performance Hub, which is a holistic management tool. This is one view of performance or a single view of database performance where you have the combination of ASH analytics and SQL monitoring. ASH analytics is used for fine-grained and transient analysis, and which encompasses the details from AW or ASH reports for any kind of deep diagnostics. Real-time SQL monitoring, you identify any kind of runtime performance problems with resource-intensive long-running SQLs. This is where we spoke about application-related tuning. So if you want to do any kind of application-related tuning where you are not sure whether your queries are running in parallel or any kind of complex statements that you want to actually have more in-depth analysis to be done, these tools are really handy. And you might also want to switch between consumer groups when you deal with autonomous databases. Are you connected to the right consumer group, or is the right consumer group that you've configured performing well for your query? Do you want to switch to another consumer group? All these decisions can be made when you do these kind of analysis. And finally, you can have insights into SQL performance and guides you into performance application tuning in a longer term view, wherein you have capability to look at these metrics as well. So this is how you would access the Performance Hub. So I might switch this into a live mode wherein we go through all these user interfaces and see how they can be managed. So I'm in the database list page wherein I have a database which I have already discovered. So I am going into that database wherein I have some load running. So this is the homepage or the DB homepage. Here you would see that there are a bunch of connections that are happening, and one of these connections, this is predominant, and I have a workload running. You can also switch to activity class to see at a high level how am I performing from a CPU, user IO, and wait. the active sessions bifurcation. Resources section allows you to understand the DB CPU allocated active sessions and data storage at a high level. These are all the metrics that we have, and these are the running sequels for the last hour or so. And you can also go to monitoring, and you can go to all metrics, wherein you have a bunch of metrics that allows you to do deeper analysis. And if you have some kind of alerts or any kind of metric collection errors that you want to deal with, you could do that as well. Any kind of actions based on these metrics, you could do that. And we are continuously enhancing the list of metrics that you could monitor via Autonomous Database. So this is kind of coming up in the next release, wherein you will see a set of richer metrics, and that would be more meaningful from an Autonomous DB perspective. If you want to go to Performance Hub for deeper diagnostics, you can go to Ash Analytics. And this is where it would ask you for the administrator credentials. I have already stored the admin credentials as a named credential, so I don't need to key in the username and password. EM already understands that I might want to use this or reuse this again, so I've saved it. And using those credentials, I log on to the performance pages. Performance Hub consists of Ash Analytics and SQL monitoring. So Performance Hub allows you to view all of the performance data available for a specified time period on a real-time basis. So by default, the performance data for the last 1 hour appears in the time slider section, and that's what you see here. And you also see a shaded blocked area in the time picker that identifies the time period for which the performance statistics are currently available. So this is the last 5 minutes or so that you see here. Now you can concentrate on the bottom half of this page for this last 5 minutes. This is how my database is performing, which is the activity graph. And the area under the graph will tell you the DB time breakdown by CPU, user IO, and any other wait event or any other wait statistics that you might want to deal with. And in this case, it also tells you that the dimensions that you might want to switch between is between the different services that you might be dealing with. In this case, I'm only connecting with the PP service, and I see that this is the only activity that is being performed using this service. But if you are connected through multiple different services, you can switch to a different dimension and see what kind of service is being used and which service is heavily used or which service is consuming most of your DB time. In essence, you can use this to do a slice and dice between multiple dimensions and do an appropriate application tuning. You can also switch to SQL monitoring and see what kind of SQLs are running, and this is currently executing SQL statement. You can highlight that SQL statement, and if you feel that this SQL is a runaway query, you can also do a kill session. And that's essentially the reason why you would need super privileges in the form of admin privileges to access these pages. And this is, in a nutshell, about the performance aspects of autonomous databases. In addition to that, you could also go to the SQL menu, wherein if you want to have more control or you want to have a behind the wheel experience, wherein you might want to take control over certain tuning tasks, that's also possible until you are completely satisfied in terms of the self-tuning capabilities. You can do your own set of analysis and then leave it to the autonomous database. You could also create AWR reports, and you have an advisor home, which gives a consolidated view of your SQL tuning advisor jobs and the SQL performance analyzer runs that you have done. In addition to that, you have security features, which we discussed about user management, roles, profiles, audit settings, privilege analysis, and ATP also supports VPD. From a schema management perspective, you deal with database objects and programs like procedures, functions. All that is possible here. And administration, as I said before, you deal with storage management. Most of it are view only. And Oracle Scheduler, again, automated maintenance tasks. These are the tasks that the autonomous database would run behind the scene. And you are not allowed to configure anything on your own. All these are configured and enabled. All you get to see is like, what is the autonomous database doing? What advices do I get? And you get to have a dashboard feeling or understanding about how the autonomous database behaves, and you get a confidence in terms of how my database is performing. So this is in a nutshell about the different set of features that you would use from a manageability perspective through EM. So I'm about to conclude my session here, wherein we kind of talk about the supported EM features for phase 1. We went through most of these features, wherein you have capability to do metrics monitoring via the DBA homepage, and then you can also access the monitoring metrics via the metrics pages, wherein you can configure incident manager, look at alert history, etc. From a performance perspective, Performance Hub, and then if you want to have a behind-the-wheel experience on your own, you could run SQL Tuning Advisor, manage SQL tuning sets. You can also generate AWR reports and also use SQL Performance Analyzer to test any kind of workload changes or any kind of database-related changes that you might want to introduce. Database administration, storage management, and automated maintenance tasks. These are mostly view or read only to have a confidence to understand, okay, is the database driving in the appropriate direction or not. Schema and security management for database objects and programs. Security perspective, you have support for VPD and privilege analysis. So all those features that you used to use for any normal database would be available via EM for autonomous dedicated as well. Now, what plans do we have for phase 2? Data movement, as I said, it's coming soon. So we would have export, import, and migration workflow, along with the consolidation planner and analysis phase, when you are completely comfortable in terms of how the entire experience would look like. High availability, we also have plans to integrate with native OCI calls, wherein you can perform most of your operations from the EM itself instead of switching between multiple consoles. If you're a fleet administrator, you want to be using one single console, you could actually perform all those activities from EM itself, and that's something that we are looking at. Performance enhancements, we will also introduce ADDM, introduction to SQL profiles, and SPM transport, which will enable you to do better migration. And automated indexes are already supported in autonomous dedicated, but from an EM perspective, we will give more exposure to that in the coming release. And we also have support for ADW and ATP serverless, and that's coming as well in 13.4 timeframe. So that's something that we would look at in the subsequent releases. So in essence, that's a summary about autonomous databases. We looked at what autonomous databases are, what deployment options do you have from a workload perspective, and also from the serverless and dedicated deployment perspective. We looked at the manageability shift from a DBA perspective and introduced Enterprise Manager as a tool that allows you to perform high-value operations that are aligned with business and the business innovations. And then looked at discovery and all the management features through a live demo. So that's it. And if you have any questions, we can answer them.
Thank you, Sriram. That was fantastic. I actually learned a lot here. I hope everybody online did too. If you have any questions, please either place them in the chat window. Unfortunately, we didn't get any chat questions because I think you covered everything so well, Sriram. Or if you'd like to ask a question live, please either I can unmute you or I'm happy to, or unmute yourself and you ask a question. I'm glad you added the coming about the serverless options, because I was like, okay, so when are we going to support serverless? that's good.
I know.
Another question, maybe while everybody's thinking if they have another question, is so autonomous. Our autonomous databases, I see we have that covered from Enterprise Manager. Does Enterprise Manager also support our other database cloud services like the BM database options as well?
Yes, we fully support. Yes, correct. And that's today with 13.3 PG. Okay. We have complete support for all VM, BM, and XSES, either deployed in public network or private network.
Oh, that's very good to know. And then, of course, Cloud Customer, we support that as well.
That's correct, yes, for Cloud Customer as well.
Okay, fantastic. All right, I see here that you have the Enterprise Manager on the Marketplace. That's good. That makes it really easy
yes.
for you guys to go out there, download it. We even have an easy URL for your blogs. If you want to go out, or for the blogs, is the bit.ly, this URL, is that for the marketplace or is that for your blog?
So that's for my blog.
Okay, great. So,
and the blog has references to the marketplace EM as well. So.
Okay, great. Does anybody have any questions? No? Okay. So you covered things too well. So again, I want to thank everybody for joining today. Our next Database Cloud Service office hours will be on September 25th at 8 a.m. Pacific time. And we're going to talk about Application Express on the Autonomous Database. If you want to go register for our Database Cloud Services, I encourage you to do that, and then you'll get notifications when our next office hours will be taking place. And you can also find all our previous recordings at asktom.oracle.com as well for our Database Cloud Service office hours. With that, I want to thank Sriram very much for this fantastic presentation about monitoring autonomous databases with Enterprise Manager. And thank you again. And for everyone, I'd like to say have a great day, and we'll see you next time on the Database Cloud Service office hours. Bye now.
Thank you, Tammy. Thanks, everyone.